Equals to 2 sine A cosine A. Sine 2A can be written as sine A plus A. In sum and difference identities, sine A plus A is equal to sine A cosine A plus sine A cosine A. And then combine like terms. And it will be equal to 2 sine A cosine A.
Prove three formulas. First, cos 2A is equivalent to cos squared A minus sine squared A. The second formula is that cos 2A is equivalent to 1 minus 2 sine A. The next is cos 2A is equivalent to cos squared A minus 1. Prove cos 2A is equivalent to cos squared A minus sine squared A. We all know that cos 2A could be written to cos A plus A, and cos A plus A is in sum and different identity. So cos A times cos A minus sine A times sine A. So we're gonna simplify it. So cos squared A minus sine squared A. And the first formula is proven. The next formula is that cos 2A is equivalent to 1 minus 2 sine squared A. We all know that cos 2A is equivalent to cos squared A minus sine squared A. So, in the Pythagorean identities, cos squared A is equivalent to 1 minus sine squared A. So we'll simplify this. So it equivalent to 1 minus 2 sine squared A. And that the formula number 2 is being proven. Formula is cos 2A is equivalent to 2 cos squared A minus 1. We all know that cos 2A is equivalent to cos squared A minus sine squared A. In this formula, we're gonna use Pythagorean identities to sine squared A. So it will be equivalent to cos squared A minus 1 negative cos squared A. We're gonna distribute the negative sign to both sides. Cos squared A minus 1 plus cos squared A. We're gonna simplify the things, so it will be equivalent to 2 cos squared A minus 1. So the last formula is proven.
Tan 2A is equal to 2 tan A over 1 minus tan squared A. Tan 2A can be also written as tan A plus A. Using the sum and difference identities, it will turn into tan A plus tan A over 1 minus tan A times tan A. And then combine like terms and it will turn into 2 tan A over 1 minus tan squared A.